Howdy, howdy. Well, next installment, we're moving on to chapter 14, where we look at simultaneous equations. And we may be looking at some things and some methods that you've never seen before for solving simultaneous linear equations, something called the determinant method. So we've got several new things on the horizon for this chapter. Looking at, first going back and looking at our graphical solution, using something called the solution by addition or subtraction, substitution, and then moving forward to the determinants and some applications, some circuit applications. So we'll be solving these simultaneous linearly equations by each of those means. So if you take a look at your textbook, you'll notice my format here has changed just a little bit because of the way the information is presented in Chapter 14. I'm going to follow the textbook really closely. So if we look at this example, 14.1 of a graphical solution where we're going to plot the solution of two lines. The first line is x minus 2y equals 4. The second line is 3x plus 2y equals 4. So we're going to solve them on the same system of rectangular coordinates. Okay, these coordinates, you can call them rectangular, Cartesian. The xy axis, there's a real. Later we'll get to the real and the imaginary, but right now we're going to look at rectangular coordinates. So in doing this, we learned in previous chapters in graphing that we can graph a solution by choosing some values that we think will yield a good result. And so it's not uncommon to choose 0 and then go from there, 0 for y, 0 for x, and try to create a solution that is close to the origin. Okay, so in doing this, you'll notice the chart for each of those where we chose y equals 0, we got a value of 4 for x. And all we're doing is inserting it into the equation. When we chose x equal to 0, we get y equal to minus 2. And then just for grins here, we chose minus 4 for one or the other and got minus 4. We did the same thing for the second equation, b. So once we laid out our plots, again, this is something that you can do in Excel, and that's why I had you do the Excel tutorial so that you can create these very quickly and not have to mess with a piece of paper and pencil to do this. So you can see here A and B intersect at some point, and that point is 2 and minus 1. So this is telling us at 2 and minus 1, we have a unity there between the two expressions, the two equations, where both equations can solve for that same set of coordinates. Because the lines intersect, there is a common solution. Therefore, this is the only solution of x equal to 2 and y equal to minus 1 for a common solution for the two equations. So that was our graphical method. That's what we covered previously. So let's move forward then to the second section in your textbook, the solution by addition or subtraction. And let's take a look at their explanation. Solving the two equations from the previous example graphically resulted in x equal 2 and y equal minus 1. Let's solve the same problem by using the addition or subtraction method. This method uses rules of algebra we have previously developed. Again, we're building and building as we go along here. We will change one or the other of the equations so that both x values and both y values have the same coefficient. If the signs of the coefficients are the same, we will subtract one equation from the other. If the signs are different, we will add the equations. The subtraction or addition results in a new equation that has only one unknown. And typically in algebra, we call this solving one in terms of another. We can now find the value of the unknown. This value is common to both original equations. The value of this unknown is then substituted back into one of the original equations, and the unknown is found. So we'll see how that works. This type of solution is very common in dealing with vectors. So, vectors solutions use this type of this solution method. So let's take an example. Example 14.2. Solve the following equations for the set of equations for x and y by the addition or subtraction method. So it looks like we've got the same expressions here. X minus 2y equals 4 and 3x plus 2y equals 4. The solution says we can eliminate the y term by addition. So we're just going to take and add these two expressions together, just like you would normally do in addition. 4 and 4 gives us 8. Minus 2y and plus 2y cancel each other's out, so we get 0. And 3x plus x gives us 4x. So we have reduced the equation through the addition of adding the two expressions together to one unknown, in this case, the x value. So we solve the equation for x. 4x equals 8 or x equals 2. Again, if we substitute x equals 2 back into either of the equations, let's put it back in the first one. 2 replaced for x minus 2y equals 4. We solve through here. Now we end up with just the y unknown. We solve for y, and we have, again, that same value, y equals minus 1, that we saw when we did the graphical method. The common values of x and y then are x equal 2 and y equal minus 1. And as before, plug the values back into the relationship and make sure that they do in fact work. Okay, so we've got another example here to go through. Example 14.3 says solve the following set of equations for x and y by the addition or subtraction method. Okay, so in this case, we're going to line the two expressions up, and we are going to go through and do a solution by multiplying by 2 in the second term, and this gives us a cancellation again for 2x. So the 2x's cancel, we get 0, and we're left with 3y is equal to 6. You notice that they normalized the negatives here. Since we had negatives on both sides, we simply normalized them. Okay, so in solving for this then, just like normal, 3y equals 6 then, or y equals 2. Substitute the value of 2 in for y in the expression so that we're left with 2x equals 6 or x equals 3. So the common values of x and y are 3 and 2. Check by inserting the values into the expressions, and you will find that you did in fact solve the two equations using simultaneous methods. Okay, so the next section, 14.3, we will look at solution by substitution.